Alright guys, how's it going? Last December, Intel invited the press to their first ever Architecture Day, where they talked at length about the future of Core, their GPUs, 10nm and their hybrid x86, with that last one being their Foveros product. And over at Anintech, as usual, Ian had the most detailed article, and I thought it amusing when, near the beginning, he talked about his love of roadmaps, for I too love roadmaps. In fact, I just love slides and presentations, though mostly for different reasons than the publisher's intent. And Intel had provided not one, but two fairly basic roadmaps, with one major change to their previous roadmaps. They're now no longer talking about CPUs, as in the whole system on chip, but we're now talking about their CPU core roadmap. Just to confuse things further, Core was also the name of Intel's microarchitecture all the way back to 2006, when it replaced the hilariously bad NetBurst, which was infamously targeted for 10 GHz. And this article from the man himself way back in 2000 details Intel's plans for 2005, and under facts from Intel, the future processors will have 400 million or more transistors, will run at 10 GHz and operate at less than 1 volt. Now instead, NetBurst hit the heady heights of 3.8 GHz and was slower clock for clock than its predecessor, and obviously nowhere near the Athlons of the time. Truly the bulldozer of that era. But the core microarchitecture which followed was something entirely different, setting the foundation for future architectures like Nehalem, Sandy Bridge and Haswell, all the way to Skylake, which cemented Intel's lead over AMD until very recently. To further confuse the issue here, Core has also been the branding since 2006, of course. So we've got the Core branding, we've got the Core microarchitecture, and the actual physical cores within each CPU. And it's that last one, the physical core, is what's being detailed on this slide. So we see the next 3 CPU cores in development, codenamed Sunny Cove, Willow Cove, and Golden Cove. And like I said, I love roadmaps and I love slides, but not just for what is in them, but also for what is left out. Coming first is the Sunny Cove core, which is the core in the new Ice Lake architecture, and it offers ST-Perf, that's single-threaded performance. It's a new ISA, which presumably amounts to AVX512, and we see this awful scalability word, which in the case of Sunny Cove has been improved. We'll just keep on guessing at what this means. But what was interesting here was this ST-Perf, and it was interesting because below it in the Atom roadmap, we also see ST-Perf. However, later on in the Atom roadmap, we see ST-Perf and frequency, and then again, much later on. Nowhere in any of the 3 core cores, let's just call them Cove cores from now on, was frequency mentioned. I found this new roadmap approach of detailing the core rather than the processor even more interesting in that this way there's no need to detail core counts either, which probably won't compare favourably to AMD's, putting it mildly. But back when I saw this, regarding this whole ST-Perf thing and this frequency, I analysed ST-Perf as basically a substitute for IPC. Now, backtracking a bit to the middle of 2018, when Intel launched their first 10nm Cannon Lake product, the 8121U. It was a dual-core chip which had the same base clock of 2.2 GHz, but a lower boost clock of only 3.2 compared to 3.4 GHz of the 14nm plus KB Lake i3-8130U. And on top of that, the new chip had no integrated graphics. It was no secret that Intel's 10nm was in dire shape. And this 8121U was simply the first concrete evidence of that. There was also this slide from 2017, I believe, by Intel themselves, which showed 10nm performance coming in lower than 14++, which is the Coffee Lake generation. And if you remember, when discussing process, performance here, higher performance on the y-axis simply means Fmax, frequency max, the top clock speed on each process. On the x-axis is the process readiness date, and if you just draw a line through this 10nm, that is bringing us closer to 2017 than 2019, and that dual-core Cannon Lake part that I just talked about, the 8121U, That had a maximum clock of 3.2 GHz compared to 3.4 GHz, which remember was 14nm plus. So if we assume that this Cannon Lake i3-8121U is first generation 10nm, and why wouldn't we, then it seems likely that Intel didn't quite meet their own performance targets, because their first generation 10nm came in a little bit below the 14 plus. Now, the man who first broke Intel's troubles at 10nm was of course Charlie over at Semi-Accurate, who has written multiple articles detailing the major issues that Intel has been having on 10nm since 2016. At one point he speculated or had info that Intel had gutted 10nm to get it out the door. In other words, the actual real 10nm that eventually launches could perform even less than what was initially promised. And in May this year at their Investor Day, Intel CEO Bob Swan and Murthy Renduchintala blamed the delay and issues with 10nm on basically over-ambition. They've both been humming this tune for quite some time, Murthy especially. Essentially, the claim is, back in 2013, Intel attempted a 2.7x density scaling for 10nm compared to the more usual circa 2x scaling. And on top of that, there were a bunch of new technologies required, like SAQP, COAG, and Cobalt. This is all related to the new process, and it was all coming in 2016, going by the 2013 plan. Charlie had actually been suggesting for some time that the Cobalt was one of the main issues they were having at 10nm. But what's really interesting about this slide is the one that follows it. This was the plan in 2013, and this is the 10nm reality. And we can see that 10nm has been pushed out from 2016 to 2019. But it's perhaps also telling that all this information here is no longer on this slide. It's still the same process, 1274 and 1274 on both slides. But that just means 10nm, the same as this 1272 here, is also 1272. And all of the pluses, it's still the same 1272 process. But what Intel apparently learned was how to better strike a balance between schedule, performance, power and cost. The question is, did they have to gut 10nm to get there? Or is this 2019 version, this 10nm plus, which was shown in this 2017 technology enhancements slide? We don't have to wait long to find out that it's at least not 10nm plus, as in the very next slide, we learn of multiple waves of planned 10nm. So it's going to be the same as 14. And we can also see that right now, this 2019 10nm is what they're calling 10nm. So it's not 10nm plus. That's coming next year. Also note of their value in maintaining a mix of nodes. And again we see 1272, 14nm and all the pluses going all the way to 2021. In the next slide, coming in at 2021, Intel claims will be their first generation of 7nm. Scaling will no longer be overambitious. They're aiming for 2x over 10nm, and they're once again planning on these intranode optimizations. So what they did on 14, what they're aiming to do in 10, they're going to be doing the same on 7. And they will also be bringing in EUV at some point in all this. But there's something else worth noting here in that 1272, the 14nm node, appears to be coming to an end in 2021. In the next slide, comparing versus TSMC, we see that Intel's game plan is investing in process leadership. And one of those plans is to extend 14nm. So they intend to continue building more 14nm capacity in order to support customer growth. 10nm will be ramping, with client systems on the shelf for the 2019 holiday season, and then servers in the first half of 2020. And finally, 7nm will be accelerated with production and launches in 2021. This building more 14nm capacity really got me here. And I found a comment on Charlie's most recent 10nm article quite telling, where he said Intel had moved 3 of their 4 fabs slated for 10nm to other processes. Some are going to 7, while others are being backported to 14nm. Before going on to say, if all of Intel's 10nm fabs pump out silicon at near 100% yields, the company will still only be able to move a fraction of their products to the process. yields are nowhere near 100%. Intel didn't build 14nm capacity out in the middle of some field. They had to do it in their current fabs, and the only realistic option they had was cutting their 10nm capacity in order to make room for it. Now, you may be wondering where I'm going with this, and hopefully this slide will help. As I've just mentioned, they'd be shipping 10nm Ice Lake client in June. And we can also see that there will be multiple product launches across the entire portfolio through 2019 and 2020. Mentioned were Xeon CPUs, GPGPU, AI inference, FPGAs and 5G. There's something missing here though. This 10nm Ice Lake chip, which I'll take a closer look at later on, is a quad-core. It is a low-power notebook chip. And we've got the Xeons, we've got all this other stuff. But where is the desktop CPU? Where are you, Core? And I think by now you can probably figure it out. There is no 10nm desktop CPU coming this year. Or next year. 2021? Maybe. If you need further convincing of this, I think that this slide will help. Process technology and packaging. Intel's PC-centric chips will remain monolithic on the same process. Now, Intel didn't specify the exact process for each chip, but we can be fairly certain that some will be 10nm and some will be 14nm. The point here though is, there is no small core, larger I/O die type architecture like AMD has. There's nothing like that coming for the PC with Intel anytime soon. They've got something similar coming to the data center, where they talk about multiple processes optimized for individual IPs, and multi-chip integration with advanced packaging. But nothing like this coming on the desktop anytime soon. And this final slide from this investor meeting was this one, showing that their 7nm lead product is actually going to be their X to the power of E GPGPU, using Foveros and launching in 2021. So this right here is very likely to be a combination of 10nm Ice Lake CPU, 14nm I/O die and 7nm GPU. But what about Ice Lake? It's 10nm. This quad core with IGP enabled this time clearly must be a step up from the disastrous 8121U of over a year ago. And we see a single core turbo of 4.1 GHz. That's with the 28 watt TDP. But for the 15 watt parts that we'll be concentrating on, the news is still pretty bad. And looking at this table over at AnandTech spells it out rather clearly. The Ice Lake Core i7 1065G7, what a mouthful that is, has a base frequency of only 1.3 GHz, which is 28% lower than both the 14nm++ Whiskey Lake 8565U and also the 14 Plus Kaby Lake R 8550U. That, however, can be logically explained by the inclusion of AVX512 on the new chips, compared to only AVX2 on the older ones. It doesn't really explain, however, the drop in the single core turbo, the maximum frequency. 4.6 GHz on the 14++ Whiskey Lake chip, that is 18% faster than 3.9 GHz of the new 10nm chips. And even the 14 Plus at 4 GHz is 2.5% faster. Ian speculated that this could be Intel's 10nm Plus, but I think given the other information we've seen on this slide, and also this older one from 2017, he'll probably change his mind on this. And sadly, it appears that with their 10nm, Intel still cannot match 14nm plus clock speeds, even 2 years later. Looking through the benchmarks though, and just concentrating on the 15 watt parts, and it's not the disaster that you may have feared. The Ice Lake chip just about has the measure of the previous generation chips. And obviously, whenever AVX512 is utilised, it wins by a mile. The IGP also looks like an enormous improvement, in some cases more than twice as fast as the previous generation. However, it's worth noting in Ian's conclusion, if it were not for the vast increase in memory speed, moving from LPDDR3 2133 to LPDDR4X 3733, one might have predicted that the Core i7 1065G7 Ice Lake processor and the Core i7 8565U Whiskey Lake processor would have performed equally. It should also be noted that the fan speed on this Ice Lake system was running at a constant 100%, so performance could actually be further reduced in actual systems. This seems pretty awful, but there is some good news, in that it is performing around equally with a huge clock speed deficit. The reason being an impressive circa 18% increase in IPC for Ice Lake over all these Skylake generation of chips. That's impressive because Skylake was already very high IPC. Normally I would say that that is a good base to work on. However, regarding 10nm, I'm not sure Intel will ever reach these 5GHz heights that we currently see on 14++. So is this the end for Intel on the desktop? Surely nothing much can be left in this 14nm plus whatever tank. 10nm is too expensive and yields too badly to be worth it for anything except for these small ultramobile chips and expensive data center products. What else can they do on the desktop? The answer to that, I believe, is likely to be this. Back where we began at the Architecture Day and the CPU core roadmap, where I noted the lack of any mention of frequency in any of these next three coming Cove parts. We've just seen Sunny Cove, Ice Lake, and its higher ST performance. Even with the lower clock speeds, it was just enough to overtake the previous generation because of the higher IPC, single-threaded performance. And next up with Willow Cove, we're getting a redesigned cache and some transistor optimizations, plus some new security features. And then finally, note in 2021, Golden Cove again has higher ST performance. But we're thinking this is all 10nm, so why would they not mention frequency too? Is frequency not going up on 10? I'm sure it will. But the answer to why they're not mentioning it here on this slide, I believe, is that Golden Cove here will be 14nm desktop CPU. Single-threaded performance will have improved over the current Coffee Lake generation because IPC will be up. However, frequency will likely be slightly down on the 5GHz-ish levels of the current desktop generation. They won't be as high as that, but they'd still get higher than what they're ever likely to achieve on 10nm. This 2021 here, that lines up nicely with the end of 14nm in this slide here. It also explains why there are no mention of 10nm desktop parts through 2019 and 2020. And it explains why the PC-centric monolithic dies are restricted by the reticle. On the desktop, Intel is going to need to add a lot more cores. Their upcoming 10 cores on 14nm versus AMD's 16 simply will not cut it. The only way they are getting close to 16 cores on the desktop though is by huge, but still pretty cheap 14nm dies. Huge because it's multiple cores on 14nm, and cheap because 14nm is so damn old now. And you've got to say that, based on the Ice Lake generation of chips, 16 cores on 14nm Ice Lake, that could be pretty good. Obviously though, in performance per watt terms, they will still be miles behind, but that is less important on the desktop. And finally, again, back at the Architecture Day last December, Raja Kaduri and Dr. Murthy Renduchintala explained that future microarchitectures will not be process dependent, and the latest products will come to market on the best process technologies available at the time. As a result, we're likely to see some of the core designs straddle different manufacturing technologies. Desktop stays on 14nm until the end of 2021. You know, it's pretty unreal, but back in my Intel versus AMD 2018 video, I think it was that one, I got slammed for suggesting that the Coffee Lake 9900K would still be on 14nm in 2018. And now I am pretty certain that they will still be on 14nm in 2021. To finish this one off, it's been a bit shorter and sweeter hopefully, as I'm still on my vacation and I'm sort of working part-time on videos and other stuff. But looking back at the missteps made by Intel's previous leadership, it is just staggering. This slide here was the one that did it for me. Their game plan to build capacity for 14nm to help support customer growth. That simply means they're building more 14nm capacity to hopefully meet the demand of all the OEMs who are losing a fortune because Intel cannot provide enough CPUs. This has been a problem at Intel for almost 2 years. Over at Tom's, they started talking about 14nm shortages in October 2017. And still now, they're planning to extend 14nm capacity? This does not take 2 years. 6 months? Maybe. The problem here though is that Intel's previous leadership bought their own 10nm propaganda. It's fine, there's nothing to see here. Everything's fine while the house burned down around them. And the worst part about it is, they don't appear to understand the market conditions and what AMD were likely to do. Had I been Brian Krzanich, the Intel CEO 2 years ago, I would have made this decision 2 years ago. Not now when it's way too late. They really ought to have known that 10nm was never going to be a desktop viable node, even then, and that the 14++ is great. Good enough to hold the desktop against AMD. The fact here is millions more people will continue to buy Intel desktop CPUs. It's a combination of ignorance, and some people will still want that ultimate gaming performance no matter what. And that's what the 9900K currently provides in most cases, and certainly 5GHz KS should. And they've got all the ecosystem behind them, all the motherboard guys, all the OEMs, all behind Intel. But you cannot sell non-existent chips. What's left of their 10nm production was always going to end up shoring up their mobile lead and then rescuing what they can in the data centre. I guess that might look like hindsight now, but what a mess you are in, Intel. Right, as always, check out the website for a bunch of new analysis, and there's a couple more reviews there and benchmarks, and I might be back with something different next week. I'll catch you later, guys.